Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the particle bounce node. So we're going to jump into Fusion where we've got a fresh emitter, and all I've got is it set up on clusters or point cluster, and I upped our number a little bit. So what we have is our particles generating right here near our emitter. Go ahead and move this over. And we're going to move it up. So I'm going to add a pBounce, and we're going to input that after our emitter. And what the pBounce does is it allows us to use this kind of as a collider. So in order to see what's going on, the first thing we're going to do is add a p directional force, so we get some force. So now we've got our emitter using yesterday's directional force node, just adding some force like gravity, bringing our particles down. And right here on this bounce, the default is line when it comes to region. So if we move this line over and go across our particles, we can make them bounce off our line. So there we go. We've got them now bouncing using this line as a collider for our particles to collide into and bounce off of. And right here, these lines you see are a common issue with particles when you have your subframes down. So when it comes time to like render or actually do your final, make sure you're going to your render node and remember to up your subframe accuracy. So once you do, all that stuff will disappear. But we're going to bring it down for this demo and jump back into our particle bounce. So in the controls, we've got our random seed, our ability to reseed and time lock, just like the other ones. And right down here we have elasticity. My mouth isn't working today. But this affects the bounce in how much your particle actually bounces afterwards, or how much velocity it has afterwards. When it's set at 1, basically the velocity that it has when it first hits that collider is the same velocity it's going to have afterwards. So if we lower this elasticity, I can't say that word. If we lower it, it's going to have less velocity after it hits our collider. So you can see that. So you can use this to kind of have your look of your bounce. Now the variance, by default, it's all going to bounce evenly. So exactly how this particle bounces is exactly how this particle is going to bounce. Your variance just varies that direction of the bounce. So we can get a varied bounce. And that way it spreads your bounce out a little bit and changes the bounce. Now down here, your surface roughness, I'm sorry. I'm going to skip this because this is kind of like your variance as well when it comes to bounce. And what this does is it introduces a faux roughness on your collider to make it bounce in different ways. So let's say this variance is, let's pretend this is like water coming down. Your variance is just your regular water kind of just spreading out a little bit after it hits this collider. What your roughness does is going to introduce these little splats or splatters coming out that are not quite following your normal motion of travel. So if I up this roughness, you can see we're getting those little onesies and twosies kind of flying out there. And that's what this roughness is doing, is kind of altering that roughness to give you a little different variance in how stuff is splashing out. So these two work together but separately to get different looks. So I'm going to bring these down. Now your spin, in order to see this, I need to stop this. Because what this spin is going to do is after your particle hits, right now your particle isn't spinning, it's just hitting and moving. But we really can't see these when we're using these points because your points really aren't going to spin much. So we're going to go to our emitter and quickly change this to N-gon, and we'll use a star, and we're going to drop this down to like 1. And we will change our size. Let's make these pretty big, like 3, so we can see what's going on. So right now you can see our stars are just dropping and they're still facing the same way after they hit our collider. What the spin does is it allows you to add spin to your particle. So after it hits, it's going to spin, kind of like something really would spin after it hit. So now you can see they're spinning, and you just use the spin to dictate how much you want that to spin afterwards. You can go backwards, forwards, however you want. So let's get our emitter back to our point cluster. And let me change that size back. So now we're back to normal. Now your surface motion, what this does is it mimics surface motion. So if I move this, you can see it's moving this around. And it does something different because we can come in here and we can add keyframes to change our motion, our actual motion of our collider here. But this will change it without having to do that. And you can change up your motion direction. Now under your conditions right here, we have the probability, just like the other ones, and our age of our start and end frames. So if we drop the probability of those hitting our collider drops. And we have the option for region up here. Now, unlike our other regions, we don't have the option for region mode. It's going to work or it's not going to work. So right here, we've got a line. You've also got the option for all, but I'm not going to click this because it's probably going to freeze my computer up. But if I go back and select all, it just does weird things. So you can use this to come up with cool effects, but that means everything is making all your particles bounce, or bounce as a collider. We've also got Bezier. So if we come in here and draw a Bezier, it's going to collide with that. And you notice something weird's happening right here. And if your collider is introduced into your emitter, because it's actually inside our emitter, it's going to do this and collect inside your collider. So if you have those weird things happening, just get your colliders out of those emitters so that's not happening. If we rewind and play it back, now it's working better and moving around. Here we go. We also have cube, which again is our 3D cube. So if you notice, you're going to see things coming in behind this cube because it's 3D. So some of our stuff that's bouncing off is actually bouncing behind and still showing. That's not these particles going in behind. Same with your rectangle. If I move my rectangle over here, it's not going to really do anything because it's a single rectangle. But if I, wrong one, if I flip the direction, now it's bouncing. And then we have sphere. And sphere would do the same thing. So, and let me inches down, so it's not going so crazy. And as a reminder, again, on this one, you're going to see your particles going in behind it because this is theoretically a 3D sphere that's interacting with this, not just a circle. So you're going to see particles bounce behind it. And the same with this, if I accidentally introduce this into my emitter, it's collecting these particles inside my collider. And each one of your regions has different settings, just like on the other nodes. And that is the particle bounce node. So I will see you in tomorrow's node breakdown.